Okay, so that's eavesdropping. A next threat at the link layer that you can think about is spoofing. So packet spoofing. In a packet spoofing attack, what an attacker is doing is adding extra packets with fake data or fake header values. Okay? So if the attacker wants to make it look like, I don't know, maybe the attacker is Mallory. Well, Mallory can send a packet to C, but Mallory could also send a fake packet and lie about the source address and replace this M here with, like, Alice's address and make it look like Alice sent this, even though Alice didn't. And the recipient will have no way of knowing any differently. Okay, so that's spoofing. Spoofing can be a big problem. So on a local area network like Wi-Fi or on Ethernet, if you have physical access to the Ethernet network, then it's trivial to introduce spoofed packets. This is particularly powerful when the attacker can also eavesdrop, because what that enables the attacker to do is eavesdrop on the connection that you are initiating, and then at some key point in that connection, introduce false data that you think came from the other side. So for instance, maybe you go to visit a website, like your banking website, and let's assume they didn't use SSL and they didn't use any cryptography, and you submitted a request from your laptop to the bank server after you had logged in saying, transfer money to this account. An eavesdropper could wait until right that point after you've logged in and then send a fake packet to the bank server saying, send lots of money to this other address. And make it look like it came from your laptop. And then the bank would think it came from you and transmit the money. And eavesdropping can make this very easy. For instance, if your connection to the bank server is using TCP, to introduce that spoofed packet, you would have to know how to fill out the sequence numbers correctly. But if you're eavesdropping, you can see what sequence numbers are being used, and the attacker can tell what sequence numbers to use.